Good afternoon. My name is CJ Radford. I'm Vice President of Cloud for Vormetric. We are a data security company based out of San Jose, focused on protecting data at rest, using encryption, key management, access control policies, and advanced logging for security intelligence. So I've got just a few slides here to give you some context around the demo itself. Just a few slides around our solution as well as our architecture, so that you have some context around the demo that I recorded for Amazon Web Services. So there's basically two components of our overall solution. One is a data security manager. It basically is the brains of our overall solution. It controls the key management, access control policies, as well as logging for the access control around our key management, around our transcription encryption agent. That leads me to the second component of our overall solution. The second one is our transparent encryption agent that resides on servers that controls access to sensitive and confidential data, as well as provides the capabilities to audit that access to that data on the server. So another slide here just to show the solution from an architectural standpoint. The two components I just reviewed, one is the data security manager, that's on the left-hand side of the slide here. That can be delivered in a physical or virtual format. Typically our end customers purchase a physical appliance and that resides on-prem. As you move to the cloud, obviously we have customers that deploy that in a virtual standpoint. That data security manager allows you as a user to maintain custodianship of your encryption keys. It also allows you to, as I mentioned prior, configure and set up your access policies around your data. That transcription encryption agent itself resides on the server. What that does is allows it allows business unit users, the approved processes and users that access that data, it allows access to that data and blocks privileged users, as well as CSP infrastructure and storage admins. It's completely transparent from a business user standpoint. There's no changes to the database or applications, and very high performance encryption REST solution. So this is basically our solution schematic of how you would deploy our solution and take advantage of the cloud. So the data security management component that I described earlier is residing here on-prem at the enterprise, using that as the brains overall to protect data within physical and virtual servers on-prem, as well as here in the cloud. And obviously by having that on-prem, look, enterprise controls that. They control their own encryption keys, their access control policies, and audit logs. Because our architecture is flexible, you can take the data security manager and deploy that in the cloud. So that's moving the data security manager from on-prem into the cloud, and leveraging it there also to control and manage data access policies around the servers that are required. So let me get started on the demo. I think that's the next bit here. So the demo consists and by the way, anyone can run this demo. It's actually available on Amazon Web Services within their test drive. You'll see it here start in just a second. But what it is essentially a data security manager, a virtual data security manager, and a single Linux box that's deployed within Amazon. As I mentioned, anyone can do this for free. There's absolutely no cost. You go to the test drive area within the Amazon Web Services site, and it's a privileged user access control. I'll be able to demonstrate how business users can access data that they're allowed to get access to, and we'll also show you how a root administrator will be blocked from data that they shouldn't be accessing. It's a pretty easy process to go through this. You go through this sign up sheet here, enter in your information, you click sign up. What happens is you'll be brought to this page, click continue, and here you'll be presented a couple of things. One is there's a test drive manual. You can actually download the test drive manual and learn about the demo itself. So very detailed directions there. And then you click the launch test drive. When you click the test drive, it takes about, you'll see the timer there. Hopefully you can see it. It takes about 25 minutes to deploy a virtual data security manager, as well as our agent within a host machine. It's a Linux CentOS box. We're not going to have to wait 25 minutes. We'll advance here. But those are the two things that are deployed on this test drive. And you can see the progress there on the right. The area on the right here titled environment. You can see your progress. Once that is deployed, you'll get an email. We'll switch to the email here in just a second. But it's worth noting that once you do have it fully deployed, it's good for 5 hours. And there's absolutely no cost to you. So you'll get this email from the test drive. What this email consists of is the URL of the data security manager within Amazon. It also provides you with credentials in order to log into the data security manager. So you'll enter those credentials into the data security manager. And remember, this is where this is the brains of our overall solution. This is where you create your keys, create your access policies, and configure your overall data protection posture around the host that you want to protect data on. So we'll go into the domain that's created for Amazon. Think about a domain as a logical separation of host keys and policies. You can logically separate in individual domains. You'll see in the domain, which is already set up for you as part of the test drive, one Linux machine that's there, that's included in the domain. The first thing that we'll do is create a key. You'll need to create a key in order to encrypt the data on that host machine. And what we'll do is we'll name the key HR AES. I mean, you can name it anything you want, but we'll name it HR AES 256 key to signify that we're creating a key that's related to sensitive HR data on the host. So you'll enter the name of the key, put some description in here, and then choose the algorithm for which you want to use in terms of encryption. So we support all the industry standard encryption algorithms. We'll do AES 256. We'll choose an expiration date. Doesn't really matter what that date is, as long as it's obviously in the future. And so then what we've done effectively is created a key that we will use on that host within Amazon. So we'll click OK. The key's been created. And we'll move on to configuring a policy. And so even though this isn't, as I mentioned prior, it's an access control test drive within Amazon. And yeah, let me just pause it. Go ahead. So the question is, do you create these data security policies across production data or test data, or does it matter? But quite frankly, no, it doesn't matter. You have end customers today running these agents in Amazon on production level data, right? So it really, whether it's test or production, it doesn't matter. It just needs to be sensitive and confidential information you want to protect. Oh, yeah, absolutely. The question is, can you use test data? Yeah, absolutely. This is a live host that's on Amazon Web Services that you can load data up to. Absolutely. And it's free of charge for you as a user. So it is a live host within Amazon that you can configure and put your data to. From a pricing standpoint, it's by per server pricing. It's not based on users or data. So we'll get back into the demo here, and the first thing we need to do is configure the host and set up users that we want to basically give permission to access the data. So these are business users that we want to be able to allow access to sensitive data on the host. And so we support LDAP and Microsoft Active Directory and so forth. And so we'll select Mary here as the business user who needs to get access to the data. What we'll do is we'll create a couple of permissions, right, that we'll put around this user. And those effects that we just selected, their permit and apply key, basically allow Mary to, from permission standpoint, to get access to the data. And apply key is to encrypt and decrypt the data. And so when you create a policy, you need a key. We go back to use the key that will attach to this policy. That's the HR AES 256 key that we created prior. And so we're done with creating a set of business users that will allow it to get access to the data and decrypt and encrypt the data. The next set of users we'll create is privileged users. These are root and system administrators that we want to block access to the data. And so we'll add a set of users called privileged users. We'll add root as a user to that user set. And you can see the privileged users created. Root is part of that. And what we'll do with root is we'll allow root to access the data, but not apply keys. So we won't actually decrypt the data from root. Okay, so we have our business users created, our privileged users created, and then all other users we will deny access into that host and audit. So any user attempts to access that data will deny access and audit. So we'll save that to the server. We'll create a policy name, HR data policy, write a quick description, and we'll save it. So that resides on the data security manager, policy saved to the server. That will be pushed to our host, the Linux host that we identified earlier. What we'll need to do on the host is actually identify what data within that host we want to apply the policy to. And we call that a guard point. So we'll set up a guard point around the HR data that we want to protect. Pretty straightforward. Very logical, right? So we'll go down and we'll select a policy that we want to create, HR data policy, and we'll click browse to look at the directory structure within that host. And we'll see the sensitive and confidential information that we want to protect, the HR directory. And we'll click OK. So right now that policy is it's almost instantaneous. That policy is being sent out to the host. You'll see that the status is red, but that'll change to green here in just a second. And when it does change to green, it means that the policy is in effect and the data is protected. So now what we'll do is, and I've got just a few more minutes, and so I think we'll be able to end on time here. Now what we'll do is we'll actually log into the host, and we'll show you how a business user can get access to the data and how root cannot get access to the data. So now we're logging in. I'm logging in as Mary. She's the business user that should be able to access the sensitive and confidential information, right? Because our solution is transparent. Mary doesn't actually know that the data is encrypted and the data is protected. It's absolutely seamless for her, completely transparent. And there she goes. She's accessing the salary raise report, and she sees a few folks here that are getting a bump in compensation. Take a look. Mary Ellison, etc. And so now, so now we'll be logging in as root to test the access control around the privileges policy. So we're logging in as root. We'll change directory to the sensitive information, HR directory. List it out, and issue a cat. The root will issue a cat command to look at that monthly salary report. That's what root sees. Now root can get access to the data, we can copy it, back it up, replicate it, conduct IT operations around that data, but the data is encrypted. You can see that the data there is absolutely just garbage. It's just garbage data. You can't actually read the data. And so root then copies the data to a new directory, tries to get access to it. It turns out to be garbage, right? Root cannot get access to the data. Right? So clear this, and we'll go back to the data security manager and make a change in our policy. And what we'll do is we'll eliminate the ability for privileged users to get access to the data. We'll just delete that. And so right now we've got two sets of users: HR users and business users who get access to the data, and all other users, including root, will be denied and audited. So let us go back to the command line interface. We're back as root. We've updated the policy. We're going to go back into the HR directory as root, see if we can see the data, and know permission is denied. And so now root is getting frustrated that he or she can't get access to the data, issue a command to become Mary. And so root SUs to Mary becomes Mary within the system. You can see that here, where the system recognizes root as Mary as a business user. He or she then goes to the HR data as Mary, and root is denied once again. So the system's smart enough to know, or our solution's smart enough to know, when a root SUs to a business user, we can catch that denial. In terms of the logging capabilities, you can see some rich logging capabilities here. So for instance, the root here is just fake as Mary, issued this command HR and was denied. So it's important, from a logging standpoint, it's important to be able to collect this data, integrate it with your SIEM, your Security Information Event Manager, and be able to pull out these events so that you can take action against things that are going on in your environment that you would want to know and be able to take action against. So I think that's all the time I have. I don't know if there's any questions in the audience. Okay, great. Well, thanks very much for your time. Sign off.